Hello everyone. In this video I am going to demonstrate you an SMPS based power supply. It is a switched mode power supply and the input is between 90 volts to 220 volts AC, and the power supply is designed to give an output of 30 volts AC at 10 ampere. So as you can see here, this is how this SMPS looks like. So this SMPS has been built on a breadboard. The circuit is still under test and it is still in design phase. So the circuit is made on a breadboard. So as you can see here, this is the mains line, and the mains line comes here and it is converted to DC and it is fed to this output block. You can see here in the output side of the circuit I am having 4 power MOSFETs. You can see here 4 power MOSFETs and here also 4 power MOSFETs. So I am using total 8 MOSFETs, and these MOSFETs are driving the output power transformer. You can see here this is the output power transformer. This transformer takes the mains voltage and it is responsible for giving 30 volts AC output. You can see here this is a ferrite core transformer, and this transformer, you can see here this is a ferrite core transformer, and this transformer is, you can see here I have made this transformer at home. You can see here I didn't use any machine. So this is the main power transformer. This is the primary of this transformer here, and this is the secondary of this transformer. This is how the power transformer looks like. So now let us explain the circuit. So this circuit is controlled with IC TL494. You can see here IC TL494 is below. You can see here, and these are the auxiliary control components. You can see here, and the output of this IC TL494 is fed to these two MOSFETs, and these MOSFETs are driving this driver transformer. You can see this is a driver transformer. So the output voltage of this circuit is isolated from the main circuit by this driver transformer. This driver transformer is used to make sure the gate pulses are proper for these two MOSFET banks. This is the MOSFET bank A and this is the MOSFET bank B. To ensure the proper gate pulses, I am using this driver transformer. So this part of the circuit, the control circuit, consists of this IC, these two MOSFETs and this driver transformer. So this part of the IC is driven by this auxiliary power supply. This is the control power supply. This control power supply is driving this control part of the circuit with the two MOSFETs and the first driver transformer. Output of this driver transformer is fed to this MOSFET banks, and these MOSFET banks are controlling the main power transformer. You can see the output of this power transformer is fed to this Schottky rectifier followed by a choke. The choke is hiding below. I cannot show it very clear to you because it is, you can see here below this black color, this is the choke. So the output of this Schottky rectifier is fed to a choke followed by this filter capacitor, and I am using one load here. You can see there is a small load. You can see here this is the load. You can see, so 360 ohms load I am using here. So, and finally the output is also fed to this LED driver module. So I am using 50C4000F driver module. So this is how my SMPS looks like. So this SMPS is designed to give an output of 30 volts at the rate 1 ampere. At the rate 10 ampere. So this is how the setup looks like. So now let's energize the setup. So I have switched on the control circuit. So now I am going to switch on the power circuit. You can see I have switched on the power circuit. You can see I am increasing the input voltage with a variac. You can see I am increasing the input voltage with a variac. You can see, and the output voltage is also increasing. And you can see here this is my LED module. My output voltage is now 21 volts. You can see the LED is started to blink, started to glow. You can see the LED is started to glow. You can see this is the input voltage. The output voltage is now 27 volts. So I am increasing the input voltage. You can see here I am increasing the input voltage. You can see I am increasing the input voltage. You can see this is the output voltage is locked at 27.49 volts. So I am further increasing. You can see this is the circuit setup. Further I am increasing. So I am now at 220 volts AC. You can see it is 220 volts DC. I am feeding here and physical input is 220 volts AC. You can see the LED is glowing with full brightness and the output voltage is constant at 27.28 volts. So this is how the setup works. So let's reduce the input voltage. I am reducing the input voltage. I have switched the input section off now. You can see the LED is off. So this is how the circuit works. Thanks a lot. Thanks for watching. You can see the detailed setup and the detailed construction details in my instructable page. I will add the instructable link so that you can find the complete design file there. Thanks a lot. Thanks for watching.